required in a particular project, and if you are breaking down a particular monolith. Even to the that it is used in this real world, right? Itself, the practical things that we do use. So after that, we will just walk through the roadmap and the future for the backend development that will just give you some edge over there, right? Then we will have the QA session at the end. Okay, so let's start. Yeah, so first one is the evolution of backend system itself. Okay, so in earlier days, if we will go through any of the service, either Amazon or any of the e-commerce portals itself, so that has been written in a whole single code base itself. So what does it mean? Let's suppose if we will talk about any of the e-commerce website or any of the banking app, so the whole service has been written in a single code base itself, right? And uh, earlier the business was not at that point, or the digitalization was not there, so business was not at a particular scale itself. But after some time, when business grow, the scale came, more users come, so whole service itself just made a huge contribution in lagging, right? So one system cannot handle the whole scale, right? So the transition happened over there. So transition was something like, from monolith, people just uh, transit to the SOA. So over here, SOA means it just means your service oriented architecture, right? So service oriented architecture is a basically it's a transformer in between the monolith microservices and the microservices. Just to give the high level overview for SOA as of now. So as SOA means, let's suppose if your service gives 10 capabilities or 10 features, then we just break down those 10 features in 10 services as per the different services. So if I'll talk about uh, Paytm itself, right? So over Paytm, we have the login first, then we can have the transitions, over here transactions, sorry. So transactions, I mean, when you will transfer money from one's bank account to another's bank account, right? So we can have like these are the two different features. First one is the login part, then we have the notifications also, then we have the whole business logic, all of those things. So as per the features, people just turn their whole single code base in the different services, right? And then after that, eventually they turn their SOAs into the microservices. So the main difference between the SOAs and microservices is microservices code is more generic, and you can use it, you can just reuse it with any of the different capabilities, right? So if I talk about the notifications, let's suppose I just break my code in two different microservices. One is notification microservice and another one is login microservice. Now both of these would be interacting to one another at a particular point only, but they both could be independent also, right? So if I want to log in, then the notification service doesn't need to be handle any of the requests. But if I want to give the notifications, then only the users who are within the product itself will be provided some of the notifications as per the uh, business requirement and all of those things. Okay. So over Airtel also, there was a billing system, right, which was monolith, and it won't be able to handle millions of daily requests when Airtel Thanks app was launched, right? So we just breaked it in the microservices so that we can just scale the things up and try to make it more try to make it handling more requests itself. Okay. So yeah, let's talk about monolith first. So okay, so over here I've just put it some of the basic things about the monoliths. So that would be the, you can say, characteristics for any of the monolith services, right? So whole project would be written in a single code base. There would be only one single project that will be doing all of the things related to the product or the project itself, right? Then the another thing would be there could only be a single data connectivity with the single code base. That's a good practice. Like people can have different database connectivity with the uh, same with the same service itself, but it's not a good practice, right? For a single service you should always have a single database connectivity. So if we are talking about a whole project in a single code base, then that's a eventual thing that there would be the single database connectivity too. So let's say if there are different features for a particular service, and that and if I am just writing whole code in a single service itself, then everything would be tightly coupled, right? So let's take an example. If I want to make some changes in my notification flow, or in my order making flow or login, so all of these flows should be like decoupled it. But when I'm talking about the monoliths, even if we are having different features which are even not different flows and different features, then everything is tightly coupled. So if I want to make the change in notification service, or if I want to make some enhancements in my notification service, or want to just give a new feature in the notification service itself, then my whole backend system would be down when the deployment would be there, or the production. If or we can say it in a other way also. Let's say if there is some issues with the notification service itself, then the login or the payment and the order, all of those capabilities would also not work if my any of the feature is down, right? But yeah, like it's, let's say if my project is not at that particular scale, and my team is also not like there are only 2 to 5 people in my team, so it's easy to deploy and build the things, right? Because there would be only the single repo, and I need to cater only that particular code base. Yeah, so for making it more generic, you can just go through the example. Like there is some college project, and you need to make you need to just define any of the feature. So you can just put it in a single service and use a single database connectivity. So that's the whole nature of monolith itself. Okay. Yeah. So let's move forward with the strengths of the monoliths. So I already mentioned, like it's a simple to develop, right? You need less infra, few moving parts, right? So what does it mean? In a monolith service, if you have only the single code base, then you need the less infra. You just need to manage that particular service itself. You are not required to you just need not required to make the things more complex, and a single infra would be reflected in between the different features itself, right? And yeah, let's say if you have the single code base, then the debugging would also be the easiest thing. There would be only the single file that would be published in my Kibana. So Kibana is one of the tool through which we can just see the logs, right? Yeah. So monoliths are good for the small teams, this is also the main, you can say, the strength of monoliths. So whenever some new thing come up in the market, or any of the new startups begin, they just go through the monolith service first. And once they are at a particular scale, so that they can just scale up the things, they just break down these features which are provided in the single code base in the different microservices. Okay, so now let's go through the weaknesses of monoliths. Okay. Hmm. So what happens? Let's say if now you want to scale up the things. Okay. So in your project, you are just providing the notifications. You are having the login also. You have the order making and the payment system also. But in the monoliths, if you want to scale up only notification service, that is not possible, because all of the code is tightly coupled and that is provided in a single microservice. So now if you want to just scale up a particular feature, now you cannot do it uh, in the on the basis of monoliths, right? So that is hard to scale a single feature. So let's suppose if I want to just scale up my notification service, or my login service or payment service, right? So then in a monolith way, you will be just scaling up the whole microservice architecture, not only the single feature. So that is one of the major uh, withdrawal for the monolith itself. Hmm. So let's suppose that another thing would be, if there are different tech stack that could be used in different microservices for providing the different capabilities. Okay, so let's take an example for this. In my project, I have a decision maker engine, right? So what would it do? It will just give me the eligibility for a particular user, either it's a fraud or not, something like this. So that particular capability would be more feasible with the Python itself, because of the main thing, that is the integration with the OpenAI and all of those things. So Python would be recommended over that particular feature. But let's say if I am talking about the different features and I want to just go through the Java, so that could not be possible when I am talking about the monoliths, because of the same service or the same repo that I'll be using, right? So that is the another drawback. Yeah. So now let's say if you want to make a single bug fix over a particular feature in a monolith service, so you need to wait with the whole software life cycle that we say. So there would be the single release that will be going within 3 to 4 months, something like this. Over there, the whole feed, all of the releases would be going, right, for the different features. And let's say if any of the feature will be like not working on a production, then whole new whole new different release would not be planned accordingly, right? Yeah, so these are some of the drawbacks due to which we just move to the microservice part, and we just decide, okay, so now we need to scale up the things. We can implement different features in different tech stack, and we need to make the releases more frequently. So these are some of the things due to which we just need to move to the microservice part. So what happens over the microservice? Now let's say if there are 10 features and you just break it down in a 10 services, so now you have 10 different code bases and they are totally independent. You can just make the changes in different repos and none of the other feature would be uh, effect, right? Then after that, the let's say each one will be having the core capabilities And let's say, so if I take an example, I had a e-commerce website which had different microservices, which had different features. One of them was the login, another one was payments, then the order making system, and then after that I have a notification service. So I can just break down these 4 to 5 features in different services and making it more independent on them. So let's suppose now I have different microservices. For the communication between the different microservices, we have different capabilities. That is the REST calls that we can make, or the gRPC calls. So gRPC stands for Google Remote Procedural Calls. They are more faster. They are more in comparison to REST calls itself, right? So what it does, just giving you the high level overview. So in REST calls, we just provide the whole communication in a JSON form, right? But in gRPC, we just transform that JSON in a binary level, right? So what happens, the network call gets lighter and the communication becomes faster between the two microservices, or the S2S call. So S2S is the server to server call. So now in a microservice, there would be the different servers for the different microservices. And the third one would be the Kafka. So Kafka is one of the messaging queue. So what happens in a messaging queue, we do publish a message from one of the microservice, and the another service, another microservice will be just consuming that particular message. Okay. So these are the main, you can say, mm, nature or capabilities that microservice provides. Okay. Uh-huh. So let's go through some of the advantages we have already just uh, discussed. Yeah. So first one is independent scaling. I have already given you the example. If you want to just scale up a particular feature in your project, then you can just do it when you are in a microservice architecture. Then after that, there would be the faster release. Yeah. So if you want to make some changes in payment service and you want to just release it down, then you are not dependent on any of the other feature of your project. And then after that, yeah, tech diversity. Now let's say if you want to implement any of different microservice in different tech stack by you, due to XYZ uh, reason, you can just do it. Now you are not dependent on the like, it's totally now decoupled part. So now you can just implement it accordingly. The main feature that microservice provide is the fault isolation, all the fault tolerance. That is also one of the, you can say, basic system design topic. So let's suppose if one of the services down for X time, then your whole project or your whole product would not be down for that particular for that particular time, right? So entire system would not be down if you are at a microservice system design level and your project is going within the microservices. So this is one of the example as per my experience in Airtel. So what happens if there are you can say peak hours, or peak, you can say, whole time range, and if you want to just scale up the payments capabilities of Airtel. So what Airtel does, it just give more infra, or you can say it just enhance its infra for that particular service only, so that if there are huge number of requests coming in my system, then I am capable enough, my payment service is capable enough for catering those requests. Okay, so there are also different challenges with the microservices that comes up. Hmm. Yeah. So now you are not talking about a single server or a single service. Now you are just talking about the different services itself. So over here, different services will be making the things more complex at a infra level. Now you are not just copying paste the same, you can say, same infra credentials or same infra uh, values for the different services. Now you are just making the whole new different services, and different infra would be there, right? And now if there are different services, now they would be just talking with the each other at a high level. So network related issues would come, latency would also be there, because I already told you that like different services can just use the different databases, right? So there would be the different, let's suppose if there are different uh, database connectivity in between the microservices, then the data consistency could also be affected over there. So we already know or like acid properties, right? So over here acid stands for atomicity, uh, and your C stands for, I think, consistency, and I is isolation, and D is durability, right? So any of the transaction, so over here transaction means okay, so making it more simpler, so transaction means let's suppose in your project you are just making the transactions. So transaction means you are just uh, writing up the things in different databases, or you are just uh, taking the help from different services itself to write up the things. Or so right over here, write up the things means you are just uh, upserting the things in your database or in your different collections, right? So that is the transaction itself. So data consistency is required in between the different transactions, and so eventual consistency would be okay. So my system at this particular time would not be the consistent, but it will be consistent after some time. So these are the some of the barriers that are there when we are just moving, or we are just making more reliable microservices. Okay, so next thing would be, yeah, so practical implementation for microservice. We will just go through those things. So okay, so what happens at a production level? Like we have the different API gateways. Okay, so API gateways are responsible for you can say your composition of APIs, and the authorization of our users also. So these are the some of the basic features that API gateways give. So API composition means if you will talk about Amazon, so or any of the other you can say app, if you will just open it in your mobile, then you will see the different visuals, right? And if you will just open it in your as a website, then you will see the different visuals and different capabilities would be there. So that is known as the API composition, and it is catered with the help of API gateways, right? So but uh, what is the configuration over the backend as per the let's suppose if a request is coming for a web server, then I'll just have a different API composition, or different API, you can say different APIs would be working. And if my request is coming from the mobile gateway or any of the, you can say, mobile server itself, so different API composition would be there. And with that, requests are coming from a particular region only. So let's say if you are trying to open Paytm, but not from India itself, so that is also catered with the help of API gateways, right? So that will eventually be blocked, because Paytm is only live as of now in India, I think. Okay, and the okay. So after that, if we are at a microservice level, then we just required the console, Kubernetes, and okay. So all of these things are related to the configurations only. Let's say if you have a API endpoint at a prod level, you have different endpoint, and at a testing level, you have a different endpoints for the APIs, right? So all of these are configurable things. Yeah. So after that, you just required. Okay. So if there are different services, now you want to just analyze your things accordingly, right? The logs that you have mentioned within the service or within the business logic, you need to just make sure like the things are working fine within the microservice. So all of these things would be done. We just use the different tools. Actually, one is them is Kibana, right? Then another things are Grafana for the infra things. Okay, so CPU utilization for a particular microservices, this memory utilization of a particular microservices at peak when these requests comes up, right? So all of these things are analytically possible with the help of different tools. You just need to configure these things in your microservice, and everything will be observable. After that, we can just talk about the resiliency. So what happens when we have a different communications between different microservices? So there could be the lag, or there could be some network issue due to which, let's suppose if I know there is some lag, then I don't want to move that particular request from microservice 1 to microservice 2. So in my microservice 2, I will have some of the resiliency configurations. Okay. So the number of retries. Okay. If request 1 is failing 3 times, then I want to retry it again or not. Okay. So these are the whole configuration that you can just provide when you are building a particular microservice. And after that, there are circuit breakers. So let's say if 10 requests are coming in my per minute. Okay, so 10 requests are coming in a minute, and within this minute only 9 are success and 1 is failed. So my circuit will not be breaked, but I have given my the configurations over my microservice, like circuit will be breaking if 10 requests are coming in a minute, and within these 10 requests only 5 are success and 5 are failed. So my circuit will be break, and I'll just again making it more normalized when again I'll just try for the 10 requests after some time, and now 8 requests are success and 2 are failed. Okay, so now it's okay, something like this. Okay, so all of these are the capabilities that you can just explore more if you want when you are at a microservice level. Hmm. So yeah, over Airtel also, like there are around 350 plus million of subscribers for our Airtel Thanks app. And if I want to scale up the things, then let's suppose if the whole recharge flow that is currently live, that is not a single project itself. It's the, you can say, mixture of the capabilities of payment service, notification service, wallet service, and the plan service, something like this. Okay, so all of these microservices just build up a single flow. Yeah. So this is one of the examples. So at a peak level, or if there are some promotions, or there are some things like IP recharge and all of those things, so you can just have a better uptime with the faster recovery things because of the microservice system design architecture. We have done this. Yeah. Okay. So if I talk about the roadmap for the backend development, let's say, yeah. So as per any startup, you, or as per anything new project, you just need to initialize your thoughts with the monoliths service itself, because you are just experimenting things, and you, if you will just give your time in breaking up the features, and not, because at a initial time you just want to make your business logic live as soon as possible, and that is only possible with the monoliths. Okay, if it's not more complex, and if you don't want to make the things more complex, and we're not talking about a particular scale, and after that you can just go through, yeah. So for the monoliths project, you can choose any of the backend, you can say, framework. So Spring Boot is a framework related to Java, and Django, I think it's related to Node, no, Python or Node. I really don't know. I think Django is related to Python itself. Okay, yeah. So these are the different frameworks for the different languages, and you can just leverage these frameworks and build up any of the project for backend system. Yeah. So after building a single project, now, and you know, like there would be some scale, right? So now you can just introduce different things. You can just break down the whole monolith service in a microservice, in different microservices. And now for the communication part, you can just uh, learn about the REST APIs, what are the REST APIs, and how databases work, what is the eventual consistency, what is the transaction, and what are the transitions. So all of those things. And for making the things more scaled up, and for making the things faster, for the more faster retrieval of the data from your microservice, you can just walk through the caching part. So how you can just cache a particular thing in your microservice. So for the cache, you can just go through the Redis and the Aerospike. Yeah. So these things you can just try. And yeah, so still, if you have some of the things that you want to optimize, then you can just after moving to the microservice, you can just introduce the whole new cloud native things. So what would happen in a cloud native things, your whole server would be at a cloud level, right? And okay, so you might have uh, listen about the Docker and Kubernetes. So what they do, they just uh, pack your whole different microservices or a whole project in a single, you can say, bin, and you just not required any of the different things to run a project from server 1 to server 2. So all of these are the leverages for the cloud native microservices. And yeah, after that you can just learn about how infrastructure works. Okay, so if these are the number of requests that my microservice will be uh, just catering. So what kind of CPU configurations, what kind of memory configurations, what kind of different kind of configurations that my service would be required, right? So all of those things comes in a DevOps part. So these are just some of the basic points that you need to focus on to just achieve your microservice part, and to know. Okay, so let's suppose if you have the single monolith, and you want to make sure you will be just breaking down your system at in just the different microservices, but you are not talking about n number of microservices, like you don't know like how many microservices are required at all. So you can just go through these steps to know how many microservices are required in a particular project, and if you are breaking down a particular monolith. So what you need, you just need a good knowledge of system designs. So there are different system design concepts, like there are three kinds of designs that are there. One is the creational, structure, and the behavioral. So you can just go through those designs, and how you can just leverage the different code designs, like low level designs and high level designs. right? And then after that, you can just have some trade-offs of distributed system, right? So what I want to like say about the distributed system, it's like okay, so let's break down it in a cap theorem and the consistency models. Okay, so within the distributed systems, so there would be more than one microservice, right? And when we talk about the microservices, they would be communicating with each other directly or indirectly. So while talking in between the microservice, cap theorem is required as per your project or as per your you can say question statement, problem statement. Okay, so cap theorem stands for the consistency, availability, and the partial tolerance. So it says you can just leverage any of the two, and you just need to ignore the third capability. So let's say if I'm talking about a payment system, then I need to make sure consistency would be there and availability would be there, and I need to ignore the partial tolerance. So if my whole payment system is down, then it would be down for everyone. But if I'm making any of the payments, then I need to make sure it is not getting deduct more than one time, right? If I'm making a payment for a X amount, and I'm just making from the UI, I'm just making the payment for first time, and the amount is getting deduct from my bank account only the first time itself, not the more than one time, right? So that would come in the consistency part and the availability part. And after that, all of those, if you are going through the system design and distributed systems, then you can just talk about the cloud native tools. Like we have Azure, we have Amazon Web Services. For Google, we have GCP. So you can just explore those tools, and yeah, after that, the infra would be there, and the security and the resiliency part. So if there is a communication between the two microservices, then resiliency is must. Because as a developer, if you know, like, okay, so these things are getting failed, so if you already know like these requests would be failed in between 5 p.m. to 10 p.m., then why will you just pass it through your system and make error visible to anyone, right? And yeah, for the security part also, you can just leverage the API gateways. There are different API gateways like Kong part and all of those things. So that is just a layer of security at your system. You can just go through different auth system also. Like we have JSON web token, right? So there would be a token that would be passed, and it will be marked expiry after 5 or 2 minutes or 6 minutes. You can just configure it accordingly. So these are the things that you should be focused on while building a scalable system and while breaking up the whole monolith service in a microservice. So in future, like what would happen, like whole your native service would be just migrated to the cloud itself, right? And there would be event driven system. Okay, so there are two different kind of systems. One is domain driven systems, and another one is the event driven systems. And if you will just talk about these things, so event driven systems are more powerful because of their capability of communicating in a faster level and in a scalable level. So you can just leverage event driven systems via Kafka or the Pulsar. So they are the messaging queue. You can just publish millions of message within a seconds, right? So these are the more focused things that would be the productive thing. Like not only the code part, you just need to uh, directly or indirectly jump to the infra part also for a particular service, right? Okay, so if we will just sum up the things that we have discussed till now, so that would be something like, if you guys will be talking about the monoliths, so you can just say they are simple and there are some limitations. And due to these limitations, we can just break down a particular monolith service in different microservices. And microservices are powerful because of their characteristics that were the limitations for the monoliths. But after some time, or if you guys are not aware of how to break down the particular monolith service in a n number of microservices, then it would be the complex thing also. Okay, so and after that we just talked about the future enhancement that will be coming within 5 to 10 years, you can say. That would be event driven systems plus serverless serverless microservices with cloud native infrastructure. Okay, so event driven system would be there so that millions of requests would be scale up within seconds. Serverless, okay, so now you not need to uh, cater the things that are over the servers, the configurations for the servers and all of those things. And after that, if your whole infra is at a cloud level, then it's a configurable thing if you want to change the infrastructure for a particular hour or something like this. Okay. Okay, so that's all from my side, and we can just move to the Q&A session if we have like any questions that you guys might be having.
Does anybody have any questions? Okay, I believe there are no questions, so we'll be ending with the session now. Thank you so much, Tanish, for that incredibly insightful session. I'm sure that everyone here picked up some great takeaways. If you're somebody who's interested in exploring the industry aligned courses offered by Tech Baron, please feel free to reach out to our team or visit our website at www.techbaron.com for more details. Also, before you leave, please make sure to fill out the feedback form. I'll just share the link in the chat. So, do take a minute before, it really helps us improve and keep our participation recorded. This brings us to the end of today's session. A big thank you to Tanish for joining us and sharing your expertise. And of course, a huge thank you to all of you for being such an audience. Until next time, stay curious, stay motivated, and keep building. I'll just be sharing the link, so do fill it out. Have a great day.
Thank you, Ayushi.
Thank you so much, Tanish.